Okay, so in this video, we will talk about inverse functions. Okay, so then the idea of an inverse function is that the input become the output and the output become the input. Okay, so first of all, before we learn the inverse function, we are going to review the one-to-one function. Okay, so a function is one-to-one if any two different inputs in the domain corresponding to different outputs in the range. That's it. Each x in the domain has one and only one y in the range. For example, like if you have x1 then corresponding to y1, then x2 corresponding to y2, and of course x3 corresponding to y3, right? On the other hand, then y1 corresponding to x1, y2 corresponding to x2, and y3 corresponding to x3. So this is the idea about one-to-one functions. Okay. And the best way to test if it is a one-to-one function is we are using the horizontal line test. Okay. Okay. So for example, like this function f right here. Okay. So we know that this is not one-to-one. It is a function because it passed the vertical line test. It's not one-to-one because it failed the horizontal line test, right? To this horizontal line, then we have two input corresponding to one output. Okay, so this is the idea. Okay, then of course, let's see if you remember. Okay, how do we indicate it's a one-to-one or not? Okay, so again, to this one, example number one, indicate if the function is a one-to-one function. Okay, so in this case, I have A, B, and C. Then you will see that A, yes, it is a one-to-one. The reason is it's passed both vertical line and horizontal line tests. Okay. How about B? You're right, it's not. Okay. Because again, it's failed the horizontal test. Okay. Then how about C? Is C a one-to-one functions? Okay. Again, it's not. The reason is it's not a function, right? Because it failed the vertical line test. Okay. Okay, so now let us learn the inverse notation now. Okay, let us f be a one-to-one function with domain A and range B, then its inverse functions, f inverse. Now remember this notation right here is not f to the power of -1, we call it f inverse. As domain B and range A is defined by f inverse of y equal to x, provided that f of x equal to y for any y in B. Okay. Then now, let's see why domain and range is kind of like reverse. Huh? This is the idea. Okay, so let us look at the mapping here. Okay, so to this f function, you see that this set A is actually the input of the f, and the set B will be the output of the f functions. So therefore, in this case, the set A is the domain of f, and the set B is the range of f. However, its inverse is actually kind of like we get it from output back to the input now. So to the inverse functions, you will see that B is the input. So therefore, it becomes the domain of the inverse functions. And then A is the output of the inverse. So therefore, A becomes the range of the inverse functions then. Okay. Okay, so again, this notation is with it F inverse or inverse of F. Remember, it's not the reciprocal. Okay. So F inverse of x is not equal to 1 over f of x. If a function has an inverse, it is said to be invertible then. Okay. Okay, so now then let's see how we work with the notations. So remember, if we have f of 5, in this case, the input is 5. Okay. Oh, by the way, you notice that this is actually a one-to-one function, right? This function f right here. Okay. So when the input is 5, then of course we could trace it back and then we could chase it, or my output is 3. Then now, if I have the f inverse of 3, okay, that means right now I look at the output is 3, and then we trace it back. Oh, I get my input, right? It's 5. So therefore, in this case, for f inverse of 3, basically is equal to 5 then. Okay. So again, you could see that here is f of 5 equal to 3, then f inverse of y, right, which is 3, equal to x, which equal to 5. Okay. Then now, let's try this. So I have f of 5 equal to 18, and then f is a one-to-one function. Then in other words, f inverse of 18 must be 5, right? Okay. And then how about f inverse of 4 equal to 2? Then f of 2 is equal to, you're correct, 4 then. This is, again, the inverse notations, okay? Okay, so to the inverse functions, let f be a one-to-one function with domain at A and range B, the inverse function f inverse. Satisfy the following cancellation properties, where f inverse of f of x equal to x for x is in A, and f of f inverse of x equal to x for f of x is in B. Okay, so let's see how is this work. Okay, now consider that we have two sets. This is the set A, and this is the set B. Okay, and now to this set right here, we actually in set A, maybe let us using x. Okay, so in this case right here, the first situations. Okay, x is in A, and then now if we go for the functions, this function f right here, then of course the output must be f of x then. Okay. Then now, if I use this output and go back to the input, okay, from output to the input, we call it the inverse now, right? So now you will see that to this one right here, my input is f of x, go through the f functions, then in this case, I could have the inverse function, f inverse of f of x is equal to what? Is equal to x then. Then this is actually is the idea. Okay, so the first situations. Then now let us look at the second situations. Again, now I have two sets. This is set A, this is set B. Okay. Now in this situation right here, I have x is in B now. Okay, and now I go through the functions, the inverse functions. So if I go through the inverse function, then in this case, I will have f inverse of x right here. Right? And then now I will put this, the inverse here, right? Become the input of the f functions. Then, of course, in this case right here, based on this, I will have f of f inverse of x. What is this equal to? Is equal to x. Okay. Then this is actually is why we get the inverse function property then. Now conversely, any function f inverse satisfy this equation is the inverse of f. Okay. So right now I would like to use the inverse function properties to show that f and g are inverse of each others. So what does this mean? It actually mean that I would like to show the two functions f and g, right? F of g of x equal to x and g of f of x if equal to x. If I could show that f of g of x equal to x and g of f of x equal to x, it means f and g, they are inverse of each other then. Okay, so now again, remember how do we actually work with the inverse notations or the function notation, okay? Remember f of x meaning what? I have f of the input is equal to 3 minus the input over 4, right? So this is actually the idea. Okay, so now, what should I do? I would like to show that f of g of x first. Okay, okay. Maybe let me use different color for the g of x. So then, this is equal to, again, just like the f function, so I will have 3 minus the input. Maybe before we do this, then, which is equal to, what is g of x? Is 3 minus 4x. Okay. Which is also equal to, now again, we have f of the input, okay, equal to 3 minus the input over 4. So it's become 3 minus the input over 4. Then what is the input? The input is 3 minus 4x. Then let's try to simplify. So I have 3 minus 3 plus 4x over 4. So we notice that this one and this one cancel. So I will have 4x over 4. Okay, I just show that f of g of x equal to x. Okay, now it is your turn. Now go ahead and try to show the g of f of x also equal to x then. Okay. Now again, to the g functions. Okay. So I have g of the input is equal to 4 minus, 4. This will be 3 minus 4x, right? And now I have g of f of x. Okay. Then, which is equal to g of 3 minus x over 4, which is equal to 3 minus 4 times x, right? Then now, of course, you will see that 4 and 4 cancel. So I will have 3 minus x. Okay, so now what we just did here, we could say that here, sin f of g of x is equal to x, and g of f of x is also equal to x by the inverse function property. F and g, they are inverse of each other's. Okay, that's it. So this is the idea. So if we have two functions, this is exactly how we show the two functions are inverse of each other. Okay, now the next two example basically is, if we have a function f, how do we actually find its inverse then? Now here is the guideline that first we would like to write y equal to f of x, and then we solve this equation for x in terms of y, if it's possible. Then we interchange x and y. The result equation is y equal to f inverse of x. Now, why do we need to interchange x and y? This is the reason. Do you see that we swap the input and the output? Yeah. So this is the reason why we swap the x and the y. Okay. Now, this is actually how your textbook is doing it. However, if you watch some YouTube video, then they will do the first step is y equal to f of x. And then the second step, they interchange x and y first. And then the last step is they solve for y. Okay. So it's a slightly, that means they swap the step 2 and 3. However, I would like to showing you this way. Okay. And then it is more clear why I show it this way in the next sections then. Okay, so anyway, how do we actually do this? Okay. So to this one, I have f of x equal to 3x plus 4 over 2x minus 5. Then let us go through the 3 steps, okay? First step, I replace y equal to f of x. And now what I want to do is I want to solve for x. Then you will see that what I could do, I could multiply both sides by 2x minus 5, okay? And then now, what I would like to do is I distribute. Now again, we want to isolate the x term, okay? Then I distribute the y here to take care of the parentheses. And now what do we want to do? We want to group all the x terms together, okay? Meaning I would like to move this 3x to the other side and move the negative 5y to the other side. Okay. Okay, now you will see what happened here. To the left side, I have a term related to x, and the right hand side, I do not have x term, right? This is exactly what we're looking for. Then now, the next step, I would like to factor x. Okay. And then of course, right now, I'm going to divide both sides by 2y minus 3. Okay. And right now, we finished the step number 2. Then now we get to step number 3. So step number 3 is we are going to interchange x and y. So what does this mean? It means that when you say x, you replace it with y. When you see y, you replace with x. Okay. And then the last step, we are going to rewrite the f of y equal to f inverse of x equal to 4 plus 5x over 2x minus 3. Okay. That's it. Okay. Again, I would like you to try B. Okay, so let's try. At y equal to 4x minus 2. And now I multiply both sides by 3x plus 1, right? Then we distribute the y. We group all the x term together. We factor the x. Then we divide both sides by 3y minus 4. So then in this case, we solve for x. Okay. and we interchange x and y. And the last step, we will write the y equal to f inverse of x. Okay, now, okay, so and now we will see that to this one, we have result f inverse of x equal to -2 minus x over 3x minus 4. Okay. Now this step right here is really important. So make sure that when you take the test, we write the y to f inverse of x, okay, to finish the problem. Okay, so we know how to find the inverse function. Then now, what do we want to do next? I would like to show you how do we actually sketch the graph, okay, of the inverse function. How do we graph it? Now, the idea to graph the inverse functions, in this case, then one thing about this is if this point A, that means this point AB is actually a point on the f functions, then the BA, okay, again, we interchange x and y, right? BA must be a point on the inverse then. Okay. So if we do it for a single point, every point, okay, each single point on f, then what happened to the inverse graph? The inverse graph basically is symmetric with respect to the y equal to x, this line right here. Okay, so let's try the problem. Okay, I would like to graph the inverse functions. Okay, so first of all, again, this is the f function right here. What I'm going to do, I'm going to label all the f functions first, okay, the point on the f functions. So for example, all, again, just the corner points, right? So we could have this is -1, -2, 1, -1, 2, 2, and 3, 3. So you will see that I found all of those points right here. Okay. And then now, how about its inverse? Then in this case, you will see that the inverse will be -1, -2 become -2, -1. We interchange x and y. -1, 1. Okay. And now let us try to sketch this. So -2, -1, -1, 1, 2, 2, and 3, 3. Now, if I want to sketch the y equal to x, this line right here, then you will see that, okay, the inverse functions is kind of like a symmetrical, right, along this line y equal to x. Okay, so now it is your turn. Now go ahead and try B now. Okay, so I hope that you get the picture. Okay. And this is the F inverse. This is the F function. Okay. Okay, so now here is actually is one application problem is related to the inverse. Okay. It's just the relationship between Fahrenheit and Celsius. Okay. So as you know, in the US, we are using Fahrenheit, right? However, if you go to Canada, then you know that they're using Celsius. Okay, so there must be a way to convert between the two systems, right? Okay, for the temperature, and then here is actually is one equation is related to the Fahrenheit and Celsius. Okay, so is f of c equal to 9/5c plus 32. Now, first of all, to this function right here, the input is the Celsius and the output is the temperature in Fahrenheit. So in this case, you have to understand that this right here is the temperature in Fahrenheit. Okay. And how about the input? This is the input. Okay. Is the temperature in Celsius. Okay. So for example, if we use this equation right here, meaning what? When you have 0 °C, it is equal to, we plug it in 0 for here, then 9/5 times 0 is 0, plus 32 is actually is 32. So 0 °C is equal to 32 degrees in Fahrenheit then. So right now, I would like to ask you, I would like to find F inverse. And what does F inverse represent? And the second, find that F inverse of 86, what does your answer represent? Okay. Okay. So then now let us try to work on A. So I have F of C is equal to 9/5C plus 32. Okay. Then again, I'm going to go through the 3 steps to actually to finish the problem. First, we are going to rewrite f of c equal to y. Okay. And then now, what do we want to do? We want to solve for c. Okay. Then I will have y minus 32 equal to 9/5c. And then remember what we could do here is we would multiply both sides by 5/9. Then we have 5/9 y minus 32 is equal to c then, right? We have this. And then now, remember the next step is what? We swap the input and the output, interchange c and y. And then now I will have y equal to 5/9 c minus 32 then. Okay. And of course, the last step is we write this into f inverse of c equal to 5/9 c minus 32. Okay. So this is actually is the inverse. Okay. Then now, what does this mean then, right? Okay. Then now, first of all, you have to understand that this C right here is not the temperature in Celsius, okay? This C right here, because we go through the inverse, right? This C right here is the temperature in Fahrenheit, right? Then what is my output? F inverse of C. This basically is the temperature in Celsius. Okay. Okay, so then to B, we would like to find f inverse of 86 is equal to what, right? Then we could just plug it in. Then 5/9 and 86 minus 32 equal to 54. We could simplify. Then my answer is 6 times 5 is 30. So what does this represent? Basically, in this case, now this 86 right here is in, right, it is in Fahrenheit. Is equal to 30 degree in Celsius. Yeah, so then this is actually one application that we are using inverse function then. Okay. So basically in this section right here, we learned the technique. How do we actually, again, introduce the inverse function, right? And then we know how to find the inverse of rational functions, or maybe this is the example of the linear function as well. Then we also know how do we actually graph the inverse functions. Okay. Nope, thank you.